he described, how time series was there. Uh, Sandeep is going to talk about time series forecasting in Power BI and how to use it. Sandeep, over to you.
Okay, thank you so much, Setu. Really appreciate it. Thank you, everyone, for joining me. And thank you to all the organizers for this wonderful opportunity. So, my name is Sandeep PAWAR. I am a simulation and data analytics engineer at Cree Lighting in US. I live close to Chicago. And I'm an Azure certified data scientist, a data analyst. My primary background is in mechanical engineering, actually. And I got into data analytics and data science about 4 years ago. I've always been involved in statistics, so kind of got involved in the data analytics stuff 4 years back. And it's been a wonderful journey so far, and I'm enjoying it. So at work, I use the Microsoft data stack. So Azure ML, Power BI, Python mostly. I have dabbled into R, but I stick with Python for most of my development. I'm very active on Twitter, so feel free to connect with me on Twitter at PAWARBI. And I blog at powerbi.com. I write mostly about Power BI, Azure ML, Python, a little bit of statistics. So if you're into any of that stuff, follow me there. And feel free to connect with me on LinkedIn as well. So the topic today is time series forecasting in Power BI. In the first half of the presentation, I'm going to go a little bit deep into how the forecasting in Power BI works. We'll cover some theory, but most of it will be demo. And then we'll also discuss what are the pros and cons and what are the pitfalls that you should avoid, what are the limitations of doing forecasting with the natively available capabilities within Power BI. And then I'll offer some recommendations to you to improve your forecasts in Power BI. In the last half, we'll look at some examples in Python. I'll also show you how you can create the same time series forecast that Power BI creates in Excel. I'll also show you how I created a dashboard using Azure ML to create a time series forecasting. So it will be an actual forecast that you can see in Power BI. So let's get to it. So the demo that I'm going to show you is actually it's a time series from a French retailer. It's not a toy data set, so it's actual data, quarterly data from a French retailer. I think it's from 2010 or something. And so let's get to it. So I'm going to open Power BI, and creating the forecast in Power BI is actually very easy. So all we have to do is, let me first show you the data that we'll be working with. So if I zoom in a little bit here, you should be able to see I have the date column. In this case, I'm not going to look at all the data because we're just dealing with the forecast. So I only have my date column and then sales column over here. So, and this is a quarterly sales data. So we are going from March to June to September and so on. So to create the forecast, all I have to do is create a line visual or a line plot. So I am right here. I go to my line chart and then drop date in my axis and then values in my, so I've just dragged my sales figure here. Let me zoom in a little bit here. So sales and then drop it into the values. One thing that you have to keep in mind when you're creating a line chart and want to create a forecast in Power BI, if I go to the x-axis here, you will see that it's right now it's marked continuous. So it has to be continuous. It's puzzling sometimes because it's hidden, and this is not something we look at very often, because if I change that to categorical, you'll see all the dates. So it doesn't treat it as a date per se, it's more of a category now. So, and if you try to create a forecast, it will fail. So when I turn that into a continuous type of variable, then you can go to the analytics pane, which is right over here. So this is the analytics pane, and then right over here is your forecast option. If I go back here and then turn it into categorical, think you won't see it. Yeah, so the forecast is not visible anymore because we have turned that into a categorical. So you go there, click on forecast, and we are presented with a bunch of options. First, I click on add, and then let's see what are the different options available. The first thing it's going to ask us is how many data points that you want to forecast for. So this is your forecast horizon. So in our case, we want to forecast 8 quarters into the future, so 2 years from now. So we'll have to change that to 8 points. Ignore last, we'll talk about that later, and detect seasonality. For now, we'll just keep it to auto. But we'll come back to that, and we'll discuss this at length with some uh, with few details there. When I pull this down, it's giving me a few options. Remember, we because we have marked this as a date column, and it is continuous, we are able to select 10 what. By default, it knows that it has detected the seasonality, and this is a quarterly data. So if I don't do anything, it will create forecast for 10 quarters based on the seasonality that Power BI has detected. If I want to turn that into 10 years, it will, let's say if we do that, yeah, so it does do that. So it will detect intelligently what you're talking about. So let's keep it with 8 here, and then let's say we want to forecast 8 quarters into the future. The one of the options that you see here is the confidence interval. So the black line here is your forecast, and the gray band, the static band, is the confidence interval around it. And the term confidence interval, it just means here that time series forecast, so forecast of any kind is statistical in nature, right? So it's not deterministic. We are predicting something into the future, and because it is stochastic in nature, it has multiple different realizations into the future. And because of these realizations into the future, there has to be some uncertainty band around it, some sort of an error band around it. And 95%, what that means is if we were to repeat this process 100 times, 95% of the times it will lie within that gray band. So think of it as an error term. So it doesn't mean that it will be your forecast would be within that, or other forecast is going to be above this or below this. Consider this as an error within which the mean forecast is going to lie. If you're curious about what I'm talking about, if you go to my blog at PAWAR BI, .com. So let me show it right to here. I have blogged about this in detail. In fact, I've covered this in 3 separate blogs because it's such a huge topic. I had to split it into 3 different series. So, and the example that I'm showing you right now, I'm using the exact same data in my blog as well. So take a look at it if you want to reproduce any of the results that I'm talking about, and if you want to look at any of the other details that you might miss in my presentation. So let's go back here. And yeah, I mean, we've created the forecast. There is not much to talk about now, right? The presentation is done. Well, not so fast, because the creation of the forecast itself is very, very easy, and Power BI team has done an excellent job of doing that. But there are still a lot of questions that are unanswered here. And what are those questions? Well, let's go here and then look at some of the questions that I asked myself when I created the forecast. How is this forecast created? Maybe we can look at some Power BI documentation, and that might help. What is the algorithm? What's the methodology that's used? What are the forecast assumptions? Forecasting is a statistical technique, and there have to be some assumptions behind it. So, what are the assumptions that Power BI is making? Those are important for us to understand when we make the forecast. How accurate is this forecast that Power BI is creating? Can we rely on it? Can it be improved? And when does it work and when does it fail? Because if we just trust it, we won't know for sure if it will work and when does it not work. So those are all important questions that we ask ourselves often when we are creating any machine learning model per se. So none of the questions that I'm asking here should be very surprising. As data scientists, we ask these questions of all the algorithms that we use. So if we go to Power BI documentation and take a look at it, you will be sorely disappointed. And the reason for that is Power BI has in documentation just shown how to create the forecast, but they don't really go into details about how the forecasts are created under the hood. What is it exactly doing? So I looked into this, researched a little bit last year, and spent almost about a month and a half researching this topic. And in my own work, I create a lot of forecasts, not just in Power BI, but using Python, Profit, deep neural nets, and lots of other libraries. And I wanted to compare the performance with Power BI is doing. And I took it upon myself to investigate that a little bit and then see if I can recreate the exact same forecast outside of Power BI. So the only thing that I could find on Power BI website about forecasting was actually a blog that was written in 2014. In 2014, Power BI, I don't think it was even around back then. What we had was Power View, which is obsolete now. And but the forecasting methodology that it's using that was used in Power View is exactly the same thing that's used in Power BI. I had an opportunity to discuss this with the Power BI development team, and they did confirm some of the things that I've discussed in my blog, and then we are going to talk about this. So, what exactly is Power BI doing to create these forecasts? So the summary of what I found was the algorithm that Power BI is using is ETS. ETS stands for error, trend, and seasonality. We will look at that in detail what that means. In terms of pre-processing the data, it is not doing any outlier detection, but it is imputing the values. So it is, and for imputation, it's using linear interpolation. If the values are if less than 40% of the values are missing, and 40% is a huge number, but I don't know how they came up with 40%, but if less than 40% of the values are missing, Power BI will do linear interpolation and then impute the missing values and create the forecast. To detect the seasonality, remember when I showed you how the forecast is created, there was an option to input the seasonality, and by default it is set to auto. So Power BI to detect seasonality, what it does is detrain the data, standardize your data, meaning set it to mean as 0 and then standard deviation as 1, and then create power spectral density and then obtain the dominant period within that. And it also looks at the autocorrelation function plot and then finds which frequencies or which periods are dominant within that plot, and decides or predicts what the seasonality is. And then it also looks at what are the typical seasonality values, like it's weekly, monthly, yearly, quarterly, and things like that. And then whatever is closest to detected seasonality, it will use that. and then it will create the forecast based on the forecast horizon that we input into the forecast analytics options. Before we go into detail about ETS and what ETS means and how it works, let's just discuss some of the terminologies associated with time series. So on the screen, what you see is any typical time series. So I am actually showing right here this black wiggly line right over here. So this line over here, this is our forecast. And in the forecast, the terms that you want to familiarize yourself is first is trend. Trend is whether the forecast is going up or going down or staying the same. So all trend is telling us is over a long period of time, what is the direction of the forecast. And if we go to Power BI, you can create and input that as well. So if I cross this one out and then go up, there is a trend option. So is it going up or is it going down? In our case, the trend is up. So it is an upward trend. The second term that you want to look at is cycle. And cycle is, in this case, is this greenish line over here. So what cycle encapsulates is over a long period of time, how is the time series changing over a long period of time. So an example of that would be maybe recession. So recession occurs, typically maybe every 10, 20, 30 years. It's non-fixed. Nobody can predict when recession is going to occur. Maybe let's say a pandemic that we are in right now. Maybe it occurs every 100 years. The next one could occur, hopefully, but it could occur sooner than that. So it is non-fixed in its length. We cannot predict it. And the third term is seasonality. And seasonality is something that occurs very frequently. And that's the seasonal part of the time series that you have to input into the option. So seasonality would be if you are collecting your data every month or every week or every day, every minute, how often you are gathering the data, what's the rhythm, what's the frequency at which fixed interval of time length that you are capturing all of your data. So that those are the terms. And what ETS does, ETS stands for error term and seasonality, and it is an exponential smoothing class of forecasting algorithm. There are two variants of which that are used in Power BI, ETS AAN and ETS AAA. What that means is the first term, error, is A stands for additive. The second is trend, and third is seasonality. So if the time series that you are using in your data has no seasonality associated with it, it is just random noise. It is just random data that it's not fixed interval of time. Then Power BI will use this ETS AAN. ETS AAN is just a fancy term for single exponential smoothing. I mean, if in school you might have heard about single exponential smoothing, and we will look at that as well. But ETS AAN is essentially single exponential smoothing. ETS AAA, on the other hand, is used if you have some fixed seasonality in your data. ETS AAA is also called as Holt-Winters method. It's an additive time series forecasting methodology. So Power BI uses ETS AAA and ETS AAN. There are lots of other different forecasting models and algorithms like ARIMA, SARIMA, and then you can even use machine learning methods but Power BI only uses ETS. So how does ETS work? Let's go to Excel so I can explain to you briefly how ETS works. So let's assume we have a time series over here. So we have a time series which looks very similar to what I just showed you. Three couple of things that we want to look at here. First, it has, let me see. Okay, so a couple of things that we want to look at here. It has a trend, so it has an upward trend. So it definitely has a trend there. Second is the time interval. So this going from this to this, and then going from that to that. This is about looking the same. So, and it occurs very frequently. So we have one, then it goes up, goes down, goes up, goes down. So there is definitely some seasonality that's associated with our time series here. So Power BI will be using ETS AAA algorithm in this case. Now, exponential smoothing, the way it works is actually very simple. All it does is, right now we are in January 2021. It's going to look at your historical data. So the last month, let's assume we are looking at a monthly time series. Last month, it's going to look at the last month's data or last month's observation, which is right over here. And it's going to assign some value to it. So it's going to assign a value, let's call that value as alpha. And what that value is, we don't know at this point. So it will start with some value, and that value is going to be between 0 and 1. Let's say it is 0.5. Then it's going to go back it's going to go 1 month back. So it's going to go to November, and then multiply the value that is in November by alpha into 1 minus alpha. And it will keep doing that in this pattern. So alpha into 1 minus alpha. Then for October, it's going to be alpha into 1 minus alpha squared, alpha into 1 minus alpha cube, and so on and so forth. So let's assume that the value for December is 1,000. So it's going to multiply 1,000 by this alpha value. In our case, we assume that to be 0.5. So 1,000 times 0.5. So that's 500. Then it's going to November. In November, let's assume it is 500. It's going to take alpha into 1 minus alpha. So 0.5 multiplied by 0.25. So it's going to multiply the 500 value by that, and it will keep doing that. And the reason why we call that as an exponential forecast is because to predict the value for January, it's going to add up all of those values and then predict what's going to happen. So let's take an example here. We'll start with 50% values. So it will take 50%. So 50%, and then this is for December. January is 25%. November is going to be 12.5, and then 6.25, 3 point. So as you can see here, these values that we assign to each of the previous observations, they are decaying at an exponential rate. So if we were to use 80% here, you can see the first value is 80%, next is 16, and after that 3.2. So only the last three observations, in fact, last three values, in fact, will capture almost 96% of the future prediction. And that's why we call this as exponential algorithm. Now the difference between, so this is how, in fact, the AAN algorithm works. For AAA, where you have seasonality, what the AAA algorithm is going to do is it's going to look at the trend, and for trend, it's just going to continue the trend. So it will capture the trend. The trend is just a linear line. So you can pretty much do y is equal to mx plus b, and then just expand that or extrapolate that into the future. So trend is going to continue. For seasonality, it's going to decompose the time series into this trend and seasonality, and then it will run or assign these alpha values to just the seasonal part of your time series. So how does the decomposition work? Let's take a look at that. Let's go ahead over to a Jupyter notebook. And let me zoom in a little bit here. We're using the exact same time series here. So I'll go right here and then I'll do this. So I'm just importing some of the standard stuff. So pandas, numpy, matplotlib. I'm also going to import some libraries from stats models. So scikit-learn does not have time series forecasting capabilities, so you'll have to use stats models for that. So from stats models, I'm going to import some seasonal decompose. So right over here, seasonal decompose, and I'm also going to import exponential smoothing and single exponential smoothing. And then I define some helper functions here. And I'm going to show you a nice trick. So if nothing else, you can at least you get something out of this presentation here. So what I'm going to do is I'm going to go here and I'm going to say copy table. So I'm just going to copy the entire table, go here, and I'm calling pd.read clipboard. So now you're able to import your Power BI data into your Jupyter notebook, and then it will import all of that data into Power BI notebook. Let me actually go here, and there is another one that I have that is formatted nicely. So let me copy the table, go here, and I'm gonna do right click in. So it's nice, in a better format here. So I've imported my data into Jupyter notebook. Let's plot the data, and then to decompose the time series, I'm just going to call this object from stats models, seasonal decompose. And when I decompose the time series, this is what I get. The first part here is the trend. So trend is going up, as we saw. And then the seasonal is the seasonal part of your time series. And this, what the AAA algorithm is going to do is it's going to assign these alpha values. In fact, if you look at the reference books, it assigns beta, but essentially the concept is still the same. So not to confuse you, we'll just keep calling it as alpha value. So it will assign this alpha value and then look back into the historical data and then assign these values. And the way it finds the this weight, alpha weight, is by just like how we do in, let's say, linear regression. It's going to assign, it's going to try different values and then keep trying this until the error is minimized, and that's how it knows that what alpha value to use. Now notice in this case is one particular thing. If I use an alpha value of 80%, um, it's going to assign 80%. It's going to take 80% of my December number, so December observation, 16% of my November, 3.2% of October, and then after that, nothing else. So even though we have a time series with 18 observations here, Power BI, because it uses this exponential smoothing, it's going to take only whatever is relevant to you. So it's not that even if you have very long time series, it's not going to help you if this alpha value is very high. Now, how do you know what this alpha value is? I'm going to show you how to find that out. But just keep this in mind, that if the alpha value is very high, then even if you have a very, very long time series, you don't need this. And this will maybe perhaps help you if you want to create the forecast in compressing your data model, so you wouldn't be using the entire length of the time series. Because it's not going to be of any value as far as type forecasting is concerned in Power BI. So let's go here. And so there are different variations of this ETS algorithm. And the additive part is in this case is because the time series, the way you can describe them, if I can describe the time series in plain English as um, this month. So let's say I am how do I describe this? So if I can describe it in a way that my sales next month is going to be 300 units more than this month, and then month after that is again that fixed number 300. So I'm still going up relative to this month, but it's going up by 300 constant units every single month. So it's not a percentage, it's just a single number, 300, 300, 300. Then it's called an additive time series. If you can describe it, and you'll have to uh, do some exploratory data analysis to find out if it is additive or not. But if you can describe it to say it's going to go up by 10% every month, then that's called a multiplicative time series. And the way to find out if it is multiplicative or additive, you look at your time series, and if it is something like, let's say, um, if it is nice pattern like this, that it's going up, whereas then this is additive. A multiplicative would be something like this, and it's going to go up and shoot up. And because in additive, this number is constant, this is always, let's say, 300, right? In multiplicative, however, this number is, let's say, whatever this number is, and next season it's going to be, let's say, 50% more than this. Then next season after that is going to be 50% more than the previous season. So if you have a high flying product, maybe a new product, then it's highly likely that you have a multiplicative time series. In most cases, it's going to be somewhere in the middle, that it is either multiplicative or additive, or maybe a combination of both. And if the trend is can be linear like this, which is what Power BI supports, but the trend can also be like this, or trend can also be like this. So if let me go back here and do this again. If my time series is like this, it is linear. If it is like this, so it's still going up, but it is going up exponentially. And if it is like this, now relative to this point over here, it's still going up, but it is called a damp trend. So this is a exponential or a multiplicative trend, and this is a damp trend. The reason for showing you this is one of the limitations, obviously, in Power BI. That if you have a linear, additive, nice looking straight line in your time series, then you are able to use this. But if it is not, then yeah, you cannot create a forecast. It will create a forecast, but it will assume that it's always additive in nature. Let's go back to Power BI here, and I want to show you a few of my other observations. The forecast that's created in Power BI, it always has a line chart. I mean, I've worked with forecast a lot. I don't think we ever use our chart or any other chart. So not limitation, but just want to show that, or just want to mention that maybe if you want an area chart, no, it won't work. The x-axis must be continuous. We already discussed that. The anomaly detector, at least for now, is disabled when you create a forecast. So if I go over here and then add an anomaly detector right over here, you'll see that the forecast is turned off. Right now, this is a limitation, but in the future, they'll probably they'll probably get rid of that. Now, this anomaly detector, which was released recently, in fact, I think of just a couple of months ago, this is a nice way to identify if you have any outliers in your data before you create the forecast. So before you create the forecast, just create an anomaly detector, see if there is anything that stands out in terms of being an anomaly, and then you can just correct that, pre-process that, or maybe correct that number before you create a forecast. Because if you use that, then your forecast may likely be, if there is an anomaly, your forecast might be erroneous, and then you turn that off and then create your forecast from there. The data labels for forecast are not available, and what I mean by that is when I create the forecast, it does not show me any label. So it shows me the forecast in a tooltip. So here we have forecast one, and what is the upper bound, the lower bound, but it does not let me show that as a label itself. You cannot extract this forecast out. So that is, I think, one of the biggest limitations here. So you cannot really use that in a measure or calculated column or anywhere, show that as a KPI or anything. And then smart narrative doesn't include the forecast in its narrative. So what I mean by that is, if I take this and copy and paste and go right over here and then create a smart narrative, which I think is this button. So it will create a narrative for me based on the data that I have, but it will just say it has increased, decreased, and what some of the numbers are and things like that. But it won't say the forecast is going to be this and this. So I think this will also be overcome in the future releases. But right now, this is also a limitation that you should be aware of. So the ETS pros and cons. Is this ETS accurate? Let's look at some of the research that has been done, and it's been my experience as well. So let me go like this. So if you work with the time series a lot, you may have heard about M3 competitions or M competitions. So just like Kaggle, or let's call it a Kaggle competition for time series forecasters. The one M5 competition actually just happened last year, and it's specifically focused on just forecasting. And the M3 competition, they looked at all the time series, different forecast methods that were used. And if you see on the y-axis here, y-axis here is the error, RMSE, or I think this is probably SMAP. So mean absolute percentage error. And then on the x-axis is the different forecasting algorithms used. The first one is the ETS. So across all the different time series in M3 competition, or all M3 and M4 competition, they actually give you not just one time series, but actually thousands of time series, and it's evaluated for all these different time series. So for all the time series that they had, ETS actually had the lowest error rate compared to, you have even more advanced time series. You have RNN, so you're using RNNs here, and then you also have LSTMs. So LSTM is here, and then let's see if there's anything else that stands out. Cards or decision trees here. M3 was done, I think it was maybe 2016, 17 or so. So XGBoost wasn't around there, but M4 competition had the same results. If you have a weekly, monthly time series, ETS works really well, and it's my experience as well. Even if you try to beat it, you'll be hard pressed to find something that works as fast and creates really robust forecasts. So ETS is good. But the problem with the ETS is it works only for high frequency. It does not work for high frequency time series. And what I mean by that is um, the forecast is ETS assumes that you have a fixed seasonality in your data. So we talked about monthly, weekly, yearly, quarterly. So all of those are fixed in number, right? If you have monthly time series, if your seasonality value is 12. If you have quarterly, your values are going to repeat every 4 periods. So your seasonality is 4. For weekly, it is 52. Your numbers are going to repeat every 52 in a time interval of 52. If you have a high frequency time series, on the other hand, let's say a daily time series, there would be multiple different seasonalities in your time series. So because it's highly granular, excuse me, the daily data will also have weekly seasonality in it, right? It might also have a weekly seasonality, monthly seasonality within it. If you have maybe an hourly data will have hourly seasonality plus daily seasonality, maybe time of the day seasonality. For example, if you're working on a production floor, you have shifts. So you have first shift, third shift, so that is also a seasonality, right? It's going to occur every 24 hours and maybe or every 6 hours or 8 hours. So the ETS cannot handle that. And what Power BI will do is, if you have multiple seasonalities in your data, it will treat it as non-seasonal, and then it will use this exponential smoothing. And what exponential smoothing does, remember, yes, exponential smoothing is AAN, seasonality value is n, it is no seasonality. And when there is no seasonality, it is only going to give you a trend, whether it is up or down. So if you create a a forecast in Power BI, and if you see only upline or a downline, and not really a nice seasonality pattern to your forecast, then that means Power BI has identified your time series as non-seasonal, AAN. And that's one of the limitations of this. So I've seen many times people use Power BI forecast in their dashboards, and they create this forecast, and they think that their job is done. But you have to understand that it depends on what kind of data you have, what is your seasonality, and then use that in your dashboard. And I would rather not show something that is inaccurate than show something, or rather, I would not include that forecast on my dashboard than show something that is inaccurate. So this is one thing that you should absolutely keep in mind. It does not let you use any additional regressors. So you're familiar with machine learning. So in machine learning, we add a lot of features, so additional features. So let's say whether it's a holiday or not a holiday, or maybe what are the macroeconomic conditions that might aid your forecast more, or how's the competition doing, and things like that. So you cannot use that with ETS. There are different variations of ETS where you are able to do that, but not in Power BI. Serene Max, for example, so seasonal auto regression integrated moving average model, the Serima X model, that's available in stats models as well. But it can use an additional feature or regressor. Even the Profit library, it lets you use additional regressors and see if it will help you in your forecast. It won't work for intermittent demand. I'll cover that in the next couple of slides, but it won't let you create an intermittent forecast. Now, I talked about how to create this forecast in Power BI, but let's go over to Excel actually. and I have this exact time series in Excel. And let me show you something. So in Excel, what I'm going to do is I'm going to extend this data. So I want to create a forecast for however many these are, and I want to create a forecast here, right? I'm going to select these two columns, and in my data tab, I am going to select forecast sheet right over here. So I select that and go to forecast sheet, and then expand that out. And then let's just select, okay, what just happened here? Let me go to forecast sheet and then just say create. Notice that Excel created the forecast for us, which looks awfully similar to what Power BI did right over here. If I click on the forecast again, well, the forecast that Power BI has created, look at this over here, forecast.ets, and then you have the time series, the date column, and the sales column selected. So what Excel is doing is Excel is using the exact same ETS algorithm. I don't know if they are using the absolute exact same algorithm, but they are at least using Power BI and Excel are using the exact same type of forecasting algorithm. The implementation could be different. We don't know that for sure, but it is just ETS. So I don't think there would be a lot of difference between them. But it created the exact same forecast for us. So recall what I just told you a few minutes ago. Power BI is only good for creating forecasts when you have quarterly, monthly time series. So why not create that in Excel? Import their data in Excel, create the forecast here. If you are able to, if it is going to create the exact same forecast, might as well use Excel, create the forecast here, and then import that into Power BI. Now you're able to use all of those values that you have created, put that in the labels or put that in your KPIs, your measures, and your smart narrative and everything. And also, as far as automation is concerned, remember this is good for monthly, quarterly time series. So you would have to manually update this, obviously, maybe monthly or quarterly. Not optimal, because when Power BI, if you're when you're handling a lot of data, you want to keep everything to be automated. But again, this is not a bad option if you are just updating your numbers on a quarterly basis. And in time series forecasting, you usually have to retune your or rerun your model if you're creating a machine learning based forecasting algorithm. You have to retrain it to make sure that you are capturing the latest seasonality and you're capturing the latest data that's available. So it's not unheard of. So yeah, you can use that option in your dashboards. Let's go over here. For imputation purposes, it's going to use linear imputation. And what that means is for this exact time series, I deleted a value from here. So the value is supposed to be 854. I deleted that, and I also deleted it from here. Power BI will create an interpolation, linear interpolation. So it will take this value, and take an average and then put that here. Same thing, it will take this value, take an average and then put that right over here. Now notice, obviously, this is 693. It's supposed to be 854. So huge difference between the two. It's supposed to be 582, but the value is 612. If I go to Power BI, let me minimize this. Let's go do this. And what I'm going to do is Control C, Control V, and I also have this missing data. So I'm gonna take this missing data, put it right over here, and now see what the interpolation did. Interpolation created, if I create a forecast for this interpolated data for the same um, for the same forecast horizon. My original data, based on my original data at the end of next year, my value is 922, but with the interpolated data, it's about $800,000. So that's a significant difference between the two. And the point of showing that is, if you have missing values in your data, you should take care of that and not let Power BI handle missing values for you. The bad part here is Power BI won't actually warn you that it's going to do interpolation. It will just do it for you, and you won't even notice that interpolation has been done. And this is especially a bad case when you have an intermittent time series. So if you have a time series like this, where let's say this is a new product, so you have some sales and not much, or zero sales, then again some sales and not much. So in that case, you'll have you may have some blank values in your data, and then if you use Power BI to create a forecast in that scenario, it will create a forecast, right? But it won't warn you that, hey, the values have been interpolated, and then your forecast would be totally garbage. So keep this in mind, that Power BI does imputation on your behalf. The last point is seasonality detection. I won't go into a lot of, I was planning on, well, actually, let me show you how the seasonality is detected. So in a very nutshell, very high level, what it is, it will detect the dominant frequencies, do some Fourier transform, and then detect dominant frequencies, and then find out what the where the peak is. So in this case, if I show you right over here, this is 5, so 4 is right over here. So my dominant peak is right here. So my seasonality is 4. But this unfortunately does not work very well in all the scenarios. So in this case, it did detect that my seasonality is equal to 4, and it worked. But let me show you one time series. This is a monthly time series actually. Even though it does not look monthly, it is a monthly time series that looks very irregular, and it has a very huge peak over here, which looks like to be an anomaly. But let's just go ahead and create a forecast. So I'm going to create a forecast here and go to forecast, add, and now notice it created a forecast for me, which makes absolutely no sense. So if I look at my recent history, it's pretty low, and it is very maybe on a downward trend, whereas Power BI is saying it's going to be significantly high up there. Also notice that in earlier case we saw points, and then months, quarters, years, all the different things, but it's not in this case, and that's an indication for you that Power BI was not able to detect any seasonality for you. So what if I make this 12 points, and then that does make at least some sense. Is it accurate? I don't know for sure if it is accurate or not, but it at least intuitively it does make sense that it is on a downward trend, and maybe it will have some sort of a shape to it, like that. So the point here is that if you are creating a time series in Power BI, always be sure to include the seasonality value in there, to make sure that it's creating the right forecast for you. And what value should you use there? If it is a monthly time series, 12. It is quarterly, then 4. If it is weekly, then 52. And yeah, so like that. Is Power BI forecast accurate? So for this exact same time series, I created different versions of it. So I created handcrafted, or I created it in Python using the same AAA algorithm. I got 6.4% error compared to Power BI 5.6. So Power BI did actually slightly better. If I create an AutoML version, an ensemble of multiple different machine learning algorithms, in fact, I got 6.3%. And this goes back to the point that that I was making here, that machine learning algorithms actually do not work very well in when you have this monthly time series data. When you don't have any other external regressors that you can use, it just does not work very well compared to ETS. So not a surprise there that even AutoML did. Well, what about if I handcraft a model myself? So I did do that, and I created an ensemble that use a damped ETS model plus a Serima, and I created. I took log of the values and then fit a Serima model to it, and then plus a profit, and then gave them equal weightage. And I looked at, I think I looked at maybe 100 different combinations of multiple different forecasting options, and this one was the best. And it created a forecast that is twice as good as the forecast from any of the other algorithms. So yeah, you can, depending on what kind of data you have, if your goal is to create an extremely robust and extremely accurate forecast, then you can create it outside in maybe using Python or R, and then deploy that in Power BI. And how do you do that? Let's go to Power BI, and I can show you that in Power BI, um, I think, let me just go through a few here. Uh, Forecast Python. Yeah. So in Python, what I'm going to do is, in Python, I'm going to use, you can use the run Python script, and then use the same exponential smoothing method that I showed you, or object that I showed you in from stats model. So you import exponential smoothing from there, and then create the predictions, and then get the predictions. And if you are able to, if you, when you do that, it will give you really nice forecast. So you can create the dynamic forecast in Power BI. So this is the forecast when it's done. This is the forecast in Power BI. It's very static. If I go over here, I can only see the forecast. It's still thinking, so give it a minute. Yeah, you only see the labels in the tooltip. But if I create a forecast using Python or Excel externally, then you are able to extract a lot of data and create KPIs, that what my forecast is going to be. Is it going to meet my target or not meet the target? And then create even more dynamic forecasts that are more insightful than just creating it in Power BI. So we looked at creating the forecast in Excel. There are some custom visuals that are available in Power BI. I wouldn't use those. Very unreliable, very buggy. They crash often. And as I don't use custom visuals at all in Power BI, because you don't know where the data is being sent and how secure it is. So you can create AutoML forecast in Azure. If you're not familiar with creating forecast models, Power BI AutoML doesn't have forecasting capabilities yet. If you want to create, or you can deploy your forecast model in Azure ML, and then use that in Power BI, which is what I did. I'm going to just show you an example. Unfortunately, we don't have enough time here, but which is what I did in this case. So if I show you, this is a forecast dashboard, one of the forecast dashboards that I created. And this is actually for multiple different products. So we have, I have three different products. So you can select, for example, one product, and it will give you the forecast, and then what are the values, whether it will meet the target, not meet the target, the percentage, and then you can even do an estimate if there is a data drift in your model, and should you be retraining, and should you be looking at your data again to make sure it is accurate, and things like that. So just like any other typical model that you create in Azure ML, so you can do that. And the way I created this, or at least how the architecture looks like, is create in Power BI. So import your data in Power BI, and then create CSVs using data flow, and then store those in ADLS Gen 2, and then use batch machine learning. So make batch inferencing in Azure ML, create the forecast, and then re-import those predictions back into Power BI, and then use that in your dashboard. So works very well. You can even scale your forecast. So if you're like Walmart or Target or very big retailer, you're able to create a parallel batch processing in Azure ML, and you can, create forecast for hundreds and thousands and millions of different products, and scale at capacity based on your needs in Azure ML, and then use those forecasts in Power BI. So to wrap up, always clean the data yourself. Make sure you understand what kind of time series you have. Enter the seasonality values manually. Um, you should be using at least 3 to 4 times your seasonality value to create the forecast. So what that means is, if your seasonality for your time series is, let's say, a monthly time series, so the seasonality value is 12, then make sure you have at least 3 to 4 times that. So 12 multiplied by 3, so 36. So you should at least have 36 data points in your time series for Power BI auto detection of this seasonality value to be correct. Like I said, if you know what your seasonality value is, you might as well just go ahead and enter that, and you wouldn't have to worry about that. Choose the correct level of hierarchy in your time series, whether you want to do quarterly or monthly time series, depending on how you do it or which hierarchy you use. You'll get different values. And all of this, I discussed this in my blog. So you can always go there, check it out. If you have any questions, feel free to reach out to me, and I'd be happy to answer those questions for you. So hopefully you found the session helpful, and thank you very much again for the opportunity. So Setu.
Hey, Sandeep.
Hey, can you hear me okay?
Yep, all good.
Okay.
You finished? Anything else you want to add?
No, that's it. I mean, do I have time here, or?
No, actually, the other session is just started, so
Yeah, that's why. Yeah, no, sure.
All right. Anyways, thanks a lot, Sandeep. Really
Yeah.
appreciate it. I think this was pretty much something new for me, so I'm certainly going to revisit this video to see what else you did.